I'm Russell Harvey. I'm CTO at RDX Works, and today I'm going to give you a demonstration of some basic Scrypto coding. We will start with just the boilerplate code that you get when you make a new package in Scrypto, and we'll work our way through a few basic core concepts that'll get you sailing under your own power with Scrypto. And in order to code along with me today, all you'll have to do is have gone to our Scrypto repository and followed the getting started steps, and then opened an IDE of your choice. In my case, I'm using Visual Studio Code, which, if you are unfamiliar with it, is not the same thing as normal Visual Studio. It is a separate product. It's freely downloadable and open source. And if you download VS Code and then install the official Rust programming language extension, this Rust-Lang, you'll be able to code right along with me. So let's get started. What I'm looking at here is what you get if you create a new Scrypto package. This is the source file that creates a hello blueprint in which we will define a blueprint which creates a component that creates an initial supply of tokens, and then will freely return a token to any caller who asks for one until its supply is exhausted. And we'll go fairly slowly through all the things in this Hello World component so that you can get your feet wet, get your basic understanding set, and then we'll actually go through and run this code and see what it feels like to interact with the command line tools, and then we'll move on to more complicated things. So let's start with line 1, this use Scrypto prelude. You'll put this at the top of every single package you create. This is basically what gets you everything you need for Scrypto. Then we declare that we're starting our blueprint section. A package can contain one or more blueprints. In this case, we have just the one, which is the hello blueprint. And then hello itself has two sections. The first is where we define our hello struct. This is where we talk about, we set out, these are the things that we're going to manage as far as state goes, whether those are resources, assets like tokens, or whether that is just data like an integer value, for example. In our case, we're only going to have a single thing. It is a vault, which we'll call sample vault. In Scrypto, resources must always be held in a container, and those containers can be either buckets, which are temporary containers which go away at the end of a transaction, they have to have been safely disposed of, otherwise you'll get an error. And then you have vaults, which are the permanent containers where a token can safely be committed to a component's state and stored on ledger. The second part of this is our implementation of hello. This is where we define the functions and methods which will do interesting things with the state that we're managing in our hello struct. Important to note that in Scrypto, we do differentiate between functions, which is what you think of as like a static function. It's a thing that does not require any state to manage. You can call it directly on a blueprint. And methods, which are things that do require reference to themselves. They do require that they be called on an instantiated component. So we'll start first with what serves as a constructor function for our hello component, and that is this function new. And this can be called directly on the blueprint. Should point out that new is not a special or reserved word. I could easily call this make hello or anything else I want. By convention, we have been sticking to usually your basic constructor equivalent we've just been calling new. And we'll go by this one line by line. The first thing we note is that we have no input parameters for new. We're always going to create it the same way. And our output is going to be a component which our caller will then be able to safely keep track of so that they can make later calls to its methods. And the first thing we have to do is we have to initialize this supply of hello token that we're going to want to give back to our callers. And the way we do that is through this resource builder. This is something you get for free. It's built into Scrypto, and this lets you create our assets within Scrypto. And if you were an early adopter and were writing Scrypto, say at the Alexandria preview event, should point out that the way we have defined our resources has changed a little bit. We moved away from what used to be you'd make a fixed supply or a mutable supply. Now we just have two types of things. Your resource is either a fungible or a non-fungible. And everything else, such as is it mintable, is it burnable, those things are controlled with flags on the resource definition. We won't get into flags on this tutorial, but we will in other ones. We'll keep things very simple for this first go-round. So you'll note that we are creating a new fungible, and we're giving it maximum divisibility. This can be thought of as the default. This is 10 to the negative 18, 1 atto, just as XRD is right now on the Olympian network, same way on, say, Ethereum. Ethereum is also 10 to the negative 18 is the divisibility of the token. We're following the builder's pattern here, where we can continue to chain on other interesting things about the resource we're building until we ultimately create it. So we're going to give it a couple of pieces of metadata, a name, and a symbol that we can easily refer to it by. And then here's the workhorse right here. This last step is we create that initial supply of 1,000 tokens. Now, these 1,000 tokens can't just land in some variable that refers to them. They have to be contained within a container, either a bucket or a vault. In this case, we're going to use a temporary container, which we'll just call myBucket, which is of type bucket. And so at the end of this call, myBucket will have 1,000 hello token in it. And type inference is present. I can actually delete that little bit where I'm explicitly calling it a bucket. We have it in there for clarity since this is the boilerplate code. So now that I have my bucket with my token supply, I'm ready to actually instantiate my hello component. And I do that by populating a hello struct. This self here, just a little shortcut for hello, since I'm in the implementation of hello. So by convention, we just refer to that as self. And the only thing I have to set up is my sample vault, and I'm going to create a new vault using the bucket I have. Important to point out that vaults, once they're instantiated, can only hold a single type of resource. So by creating a vault with this bucket of hello token, that vault will forever only be able to hold hello token. And if I try to put something else in it, I'll get a runtime error. And then having done that, I can instantiate it, which will create it, in our case, on our ledger simulator. Important to point out, you'll see I haven't actually put in a return call here. By convention, the last expression, the value of the last expression is automatically returned if you don't explicitly return it. I could also do this if I wanted to. Let component equal this, and then I could return component. And that works just as well, whatever style you prefer. So let me undo that bit. So calling that, we'll get it can be called directly on the blueprint because it is a function. And that's going to create our supply, put it into our newly created hello component, and return the address of that to our caller so that they can now refer to it later. And to do something interesting with that thing we've just created, we have this free token method. You'll notice there's a reference here to self. This means it is a method. It can only be called on a component. You'll note this little and mute. Mute is for mutable. The reason this is mutable is that we are intending to change our state by giving away one of our tokens, and so we require a mutable reference to self. If I had something that wasn't going to change my state, such as, let's call it get token balance, I would not need a mutable reference to myself. I can just return my sample vault amount, and as I'm not changing my state, I'm just returning information, I would not require a mutable reference to myself. So coming back to free token, we have a info line here where we can print out some details about what's about to happen. We're saying that we have our current balance of hello token in our vault, and we're about to give one away. And then as our last step, we will perform the take operation on our vault. This gets us a bucket that will have a single hello token, and because it's the last expression, that will automatically be returned. And that's it. That's all we need to do to return one hello token to our caller. We don't concern ourselves with what the caller is going to do with it. You can think of, in many other places you may have programmed, if you've been programming in the blockchain or distributed ledger space, that you would think of it as you want to pass an address or something like that, and then you would yourself do the send to that address or manipulate a contract that manipulates that address's balance. In Scrypto, the pattern is not to do that. The pattern is to basically recompose transactions by pushing these buckets of resources around in between. And so all that free token needs to do is to basically just take the token out, put it in a bucket, and then emit that bucket. And then the caller is free to do what they want with it. They could store it in, say, an account they control, or they could chain it into some other call to another component in the same transaction. That's at the caller's discretion. So now I'm going to open my terminal, and let's actually run this thing. Make sure I'm in my correct directory to start. And then I'm going to call RESim, Radix Engine Simulator, which is what we use as our interface to interact with your local file system simulator. And I'm going to publish my package. Publish will automatically perform a build if one is required. And we are going to wind up with, I will skip past some of these other details and go straight to what we got as a result, which is one new entity, which is this package at the following address. Now, at this stage, we're not keeping track of these addresses for you. You will have to save them to a local variable, make your life easier. So I will export that package address. And now I'll be able to reuse it later in my other calls to RESim. So now that my package is on there, my blueprint is now callable. I can refer to it from the package, and I can call my new function, which will let me actually instantiate my component. So to do that, we're going to use RESim call function. And I should point out that all these RESim things have this -- help available, which will tell you what are the various options that you can use, the flags you can set, and so forth. And RESim itself at the top level also has -- help. Get a little more space here. Okay, so let's call our function on our, we put in the address of the package that we saved to a variable. Then we have to put in the blueprint name, which is hello. And then we have to put in the name of the function that we're going to call. And again, that functions and methods are different. They use different commands in RESim to call them. It's an easy thing to get tripped up on if you're intending to be calling a method and you use call function instead, and vice versa. So package address, blueprint name, and then our function name, which is new. If we had any parameters, we would just add a space, then do each parameter separated by spaces. We don't have any parameters in this case. So I will run that. And I have forgotten to, I need to create an account to be running in the context of. So at present, the transaction model that is defined for Radix Engine v2 is not completely implemented from this command line level. And so what happens is that RESim performs a little bit of magic on your behalf in that it wants an account to act as, and that account is a component that holds some resources, by default just XRD, and then in doing any calls that you give it, any function calls or method calls, it basically would automatically withdraw from that account on your behalf, make the call to the function or method, and anything that comes back will be deposited back to your account. In this case, we're going to not be doing anything to do with tokens. They're doing a new one, but I do need to have an account to act as. And so I will call this new account method, which creates a account for me. I get a couple of important pieces of information, a public key and an address. I won't actually need the public key for this demo, but there are certain cases, such as switching from account to account, where you do need to save the public key. But for now, I will just export this account address as my ACCT variable. And I get a little note here that as this is the first account I created, it has been set as your default account. That means that RESim will be acting as that actor every time it performs any calls. So now let me go back to what I was doing, which is calling a function to make a new hello. Now that works successfully. And again, we'll skip past this stuff for now. This is basically the transaction being built on your behalf by RESim. Cut down to what happened at the end. So we got two new entities. Number one is a resource def. This is the resource definition of our hello token. I'm going to export that as hello token. And then I got the address of my actual hello component. And I will export that as well. Good time to talk about, there's another useful bit in RESIM called show. You can do show followed by any address, and you will get information about whatever address you asked it to interrogate about. For example, if I look at my account, I see that I got a resource definition, which is Radix, and I have 1 million XRD. This we do every time we create an account. We give you a million XRD with the account because we assume you're going to want to have something to spend. And that's all that's in that account. And we can also note that the blueprint that my account was instantiated from was this blueprint name account. This is a baked-in blueprint with Scrypto where we provide an implementation of an account. In later phases, there's no reason why you wouldn't be able to use a custom account if you wanted to. The Radix Foundation will provide possibly multiple flavors of account, and it's up to the user whether they want to use one provided by the Radix Foundation or one provided by a third party or something they wrote themselves. The important point is that as of Radix Engine v2 and with Scrypto, you do not hold resources directly on an address. Don't think of it as something like Ethereum where I can just send send the ERC20 or send Ether to an address and be able to hold it directly. In REV2, all resources are always held by components, and so it's expected that everybody will need to have an account component or something similar in order to hold resources that they control. You don't go directly to an address. I'm getting ahead of myself. Let's look at a few other things that we've done. So I looked at my account. I can look at the hello token that I created, and I'll see that it has no interesting flags on it. Again, we'll talk about flags another time. As the symbol I created, the name and the supply is 1000. And if I look at the component I created, I can see that it was from the hello blueprint, and I can see that I have 1000 of this resource definition, which is the hello token that we just looked at. So now let's actually call this method. Now I'm using call method instead of call function. And again, -- help is available for everything. And I can see that in call method, I'm going to need a component address and the method name and then any arguments. So my component address I have saved in the component variable. And the method I'm going to call is, I believe, free token. Yes, it is. And even though there is a parameter in that it is a reference to self, this is implicit. You do not have to supply that parameter. So from a calling perspective, this has no parameters that I need to provide. So I will call that free token. And I get a successful result. And I will see that I logged that at the start of that, I had 1000 hello token, and I gave one away. No new entities were created because all we did is we took one hello token out of our vault and we returned it to our caller, and RESIM on our behalf put that into our own account. So now if I look at our account again, I will see that I now have one hello token and I have 1 million XRD. And if I call this multiple times, I'm just going to do several calls to hello token, I will see that now when I look at my account, I have 5 hello token, my million XRD, and if I look at my component, I will see that my balance was reduced by 5 overall. So that's the most basic interaction you can do in Scrypto, is create a resource, store it in a vault, and then when called upon, you can give it away. At this point, we're going to transition to doing something slightly more interesting. We're going to do a Radix favorite, which is a Gumball Machine. And in a Gumball Machine, all we're going to do is provide a way for the caller to send us some tokens. We'll just use XRD as an easy example. And in exchange for the correct amount of XRD, we are going to give the caller a gumball. So let's set this up. I'm just going to repurpose the code we have already. Let me hide my terminal to get a little more room here. Let's change our struct to be a Gumball Machine. And what am I going to need to hold? Well, I'm going to need a vault to hold my gumballs. I'm going to need a vault to hold the XRD that I'm going to take in. And just as an example, let's also do a user configurable parameter here. Let's make the price something that the user can set at instantiation time. And that's just going to be a bit of data, not a resource, not a vault. I think that's all I require. We'll come back and revisit it. If I have left something out, I'll now change my implementation to be Gumball Machine. I will leave my constructor equivalent as named new. And what am I going to give back? I will return, I believe, just the component, but we'll change it if necessary. Okay. So we can actually reuse a bit of this code. Let's change it to, we're going to create our stock of gumballs first, but let's make our gumballs indivisible, because we'll say the smallest amount of gumballs you can have is just one, as in there are no fractional gumballs permitted. And let's change our metadata to be a gumball for the name, gum for the symbol, and let's create 100 of them as a start. Okay, that will get my, let's call that my gum bucket. I'm not going to worry about the type inference. And let's let the user set our price as well. Let's say that the price is a decimal, which can come in from our caller. This is actually all I need now at this point to go ahead to instantiation, because my collected XRD vault is actually going to be empty. So let's start with the Gumball vault. That's just called Gumballs. That is a vault with bucket, gum bucket. And our collected XRD, this is going to be a new vault, and we will use, there is a Radix token as a constant you can use. I'm not sure why my source completion has conked out on me there, but usually in VS Code I actually get that successfully looked up and auto-completed for me. And then the price is going to be whatever the user told us the price is. And then I will instantiate that Gumball machine and return it to the caller. Okay. And let's delete all this and get our buy gumball function. So when the user buys a gumball, we are going to alter our internal state. We expect that if they give us the correct amount, we're going to be giving them a gumball and taking their XRD. So we'll get a mutable reference to ourself. And we need the user to give us their payment, and that's going to be in the form of a bucket. They're going to give us a bucket of XRD. So what's the first thing we're going to do? Well, let's check that the user gave us the correct amount of money. Let's check that the payment, that amount, is the same as our price, amount of XRD sent. And at this point, I could actually, if I wanted to, I could assert that the payment itself was provided to me in XRD and give the user a friendly error in the event that they sent me the wrong token. But I'm actually going to skip past that and just go straight to trying to place the payment in my vault of XRD. I'm going to call put, which will take the contents of their payment bucket and basically dump the entire supply into my collected XRD vault. And in doing so, I will have consumed this payment bucket, and I won't get a runtime error saying that I didn't manage to successfully sync that bucket that was passed in somewhere. In the event that the user passed me anything besides XRD, I will get a runtime error at this point, because the vault was initialized right here to only hold XRD, the Radix token. And if I put anything else in it, I'll get a runtime error. Important to point out that, again, the XRD asset itself is not special to Scrypto. It's just a fungible resource like any other, and I could just as easily have collected, a Russell coin or something like that I created. Doesn't matter. It's not the way you interact with XRD is no different than the way you interact with any other token in the system. So now that I've put my payment away, let's give the user back a gumball. Take one. And that's all that I need to do to let the user buy a gumball. Now let's try this thing out. I will go back to my directory. I will reset my ledger to RESIM reset. Basically clears anything you had deployed on your local file system simulator. It destroys it all. I'll make a new account, which you'll notice it now thinks it's the first account again, because after doing reset, I destroyed the one I created before. I will save that address, and then now I will publish the code I just wrote, and it seems that I misremembered what this is called. Let's go back to the visibility max. Or in fact, that's just a shortcut for 0 for indivisible. And we'll go figure out what the correct term for that was later. Let's try again. Oh, and also I have one more error. I referred to price without a reference to self. So we'll see right here, it's complaining that, hey, you meant to do self.price. I have no knowledge of what price is. Okay, let's publish again. Nope. Oh, I forgot to save. Up top, try again after I actually saved my fix to self price. And I created a new package. So after a few missteps, I have my Gumball Machine published to my local simulator. So just as before, I export that package address so I can use it again. And now I will do call function on that package address. Next is the blueprint name, which is Gumball Machine. And then the function name that we're going to call is new. And in this case, I have to supply a parameter for the price. Let's say it's going to be 10 XRD per gumball. That runs successfully. And I got my gumball resource definition. And I got my component. So let me take a look at these. Let's look at gum. We'll see that we have a supply of 100. And if I look at my Gumball Machine, we'll see that I actually have 2 vaults in here. Number 1 is the Gumball's vault that has 100 gumballs, and then there's an empty vault which has XRD within it. And in fact, I need to save this address for XRD because I'm about to use it in calling this thing, because I have to pass a bucket of XRD to the buy_gumball function, else it won't work. Let's do that now. Do call method on my component address. We're going to call the buy_gumball method. And I need to supply my payment as a parameter here. And the way this is done in RESIM is I'm trying to get a quantity of a resource from my account that I'm acting as. I put in the amount I want to get, followed by a comma, followed by the address of the resource. So 10 XRD is what I want to spend. That's what I'm going to pass to buy_gumball. And now let's go ahead and run this. And RESIM constructed that transaction on my behalf, and I wound up with, there was no logging and no new entities were created. But if I look at my account, I will see that I now am 10 XRD poorer, and I am 1 gumball richer. And let's actually call that several times to get, what did I make my payment? 10. Let's call this 10 times. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now I have 10 gumballs. And just to show you, if I tried to buy a gumball using payment that wasn't XRD using gum, you'll see the error you get back out. So if I call my method now using 10, instead of spending 10 XRD, I'm going to try to call it spending 10 gum. I get a failure saying that the the resource that was expected to be put into that vault did not match our expectations, and hence we get a runtime error. So what's wrong with this picture at this point? We can sell gumballs, great and all that, but what if we wanted to be slightly more sophisticated? What if we wanted to make it so that the user was able to put in any amount of payment as long as it was sufficient to meet the price, and we just give their change back to them? This is slightly contrived for something like a Gumball Machine, but for a Uniswap equivalent, it is quite commonly the case that when the price of a thing can change by the time your transaction is actually executed, it can be very useful to be able to supply more than might be strictly necessary by the time your call is run and give change back accordingly. So let's do that. First thing we'll do is we will kill our assertion on the payment amount. Let's just put in from their payment, let's just take what we need. Let's just take the price out. So what you could think of what's happening here, if I do payment take self price, this is equivalent to me doing let temp bucket equal payment take. This pulls out our 10 tokens, puts them in a temp bucket, and then we just put into collected XRD the contents of that bucket, and then I'll give one gumball back. We shorten that back to a single line and get rid of this. Now, if the user were to pass in an exact change, you might think that this would work just fine, but let's see what occurs if we do that, because what we're going to point out here is that in Scrypto you have to be very explicit about disposing of having proper sources and sinks for any buckets or references to buckets that come into your method. So let's republish this, and there's a little trick to this. I've changed my code up here, so I need to republish. And I can actually explicitly specify the address that I want to republish to. In this case, my package address, I want it to be unchanged. And when I do that, now if I call my component again, it's already been instantiated and everything. The code it's using when BuyGumball is called will pick up the latest at this point. The only time that you can't just publish your package to the same address is if you have done anything to monkey with the contents of the struct. At that point, you'll have to publish to a new address and reinstantiate your component and start from scratch. Let's try calling BuyGumball at this point. I know that if I give it 10, that's the correct amount. But when I do this, I'm going to get a failure, and try adding -- trace, which actually I skipped past too quickly. In my call, if I want additional information on what went on, add this -- trace, and this will print you some extra debug info. And you'll see that what's happened is we have this little warning here that we have a dangling bucket. In this case, this is the XRD address. Because what happened was, even though we didn't wind up with any XRD that would have vanished because we sent in 10 and 10 were taken and placed in, the Radix engine guarantees that all buckets have been safely dealt with on any individual call. So what happened here is that we may have taken out the contents of that we were expecting, the 10 XRD, but what if the user had passed in something like 11? You'd now have at the end of this, you'd have your payment bucket would have had 10 taken out, but there'd be one just floating in space. And if you didn't safely put it in a vault, then that token would essentially be inherently burned. It would vanish. It would be untracked anymore. This is not permitted under the rules of the Radix engine, and so we get an error at runtime saying that this is impossible. You have to account for completely dealing with the contents of that bucket. So in our case, what we want to do is give the user back change. And the way we can do that is, instead of returning back just one bucket with the gumball, we're going to return a tuple which contains two buckets. And the first thing in our tuple will be the gumball, and the second thing will be whatever change is left in the user's payment. You can think of it just like a physical bucket. We're not dealing with just a variable here, where if I took something out of it, maybe I didn't modify the variable state. In this case, if I had a bucket that had 10 XRD in it, and I took out 10 XRD, I still have a bucket which is a valid object. It just has 0 XRD in it. It's perfectly acceptable to have an empty bucket. And in this case, my bucket with quantity 0, if I had passed an exact change, will be returned. And if I had passed in more than exact change, then whatever is left over will be returned. So now that we've done that, I will republish. And that will put me, that will have me be using my latest code. I hope I remembered to save up top, else this is going to fail right now. And let's buy Gumball again. And now this worked successfully. Let's just take a quick look. We have 999,890 XRD. Let's call again, giving way too much money for the Gumball. And now if we look at our accounts, we'll find that we didn't overspend. We just had the 10 that was the price of the Gumball. Some people might feel uncomfortable with the notion of supplying a component with more than it specifically needs. This is, of course, up to the developer to decide if you wanted to have a thing where your individual method could take in more than is strictly required and return change. This is a pattern we use a lot on the examples that we produce. I do want to point out that on the way the transaction model works, in the Babylon wallet, you are able to see the expected results of a transaction before you sign it. So in the case of something like where you are passing, 1,000 XRD to buy Gumball, you would still see that the predicted delta of the operation is that you would only be actually losing 10 XRD, and that you'd be gaining 1 Gumball, and that the other extra you passed in ultimately did not leave your account. But again, up to the developer, up to the consumer, whether they ever want to follow this pattern of allowing you to submit extra and return change. So we're still missing one thing here, which is a way to get our collected money back out. So let's implement that. Let's call it withdraw or collect XRD. And that's going to return a bucket. And all that we need for this is our collected XRD to take all. And that will give our caller back all the XRD. Of course, there's currently no way to prevent anybody from calling our collect XRD and taking all the money from our Gumball machine. Which takes us to the last concept that I want to introduce on this tutorial, which is the use of a concept we call badges. You'll be familiar from programming on other ledgers with a pattern of using your caller's address, or the originator of the transaction, as the means by which you determine whether someone has a certain amount of privilege to do something that is not an action that anybody can take. We believe this leads to a lot of problems, especially when you get into the realm of where you have smart contracts managing other smart contracts. It's easy to introduce bugs where you can basically escalate your privilege when you shouldn't. You can authorize an action that the developer did not intend for you to be able to take. So the way we solve this, our pattern in Scrypto, is this use of badges. And that is, a badge is a name for a resource which is used predominantly for authorization. And if you hold that resource, if you hold that badge and you present it to a component, you can think of it as flashing the badge saying, hey, I'm authorized to do this thing. And you actually don't have to actually pass the badge in, as in the component that you're talking to would not have the right to retain the badge, even if it was malicious. but you can present the badge and show it in a way where it is you can think of it as it's a borrow saying, hey, I prove to you that I am holding this, this badge, this resource, and so I am an authorized actor to take this privileged action. Let's get into implementation of that. And I will close down my terminal to get a little more space. Let's actually mint this badge that we're talking about. Let's call it an admin badge. And we'll make a new, we're only going to make one of them, and it's going to be a fungible. We'll make it indivisible. Let's just call it Gumball admin. And we won't bother with a symbol. And the initial supply is going to be just one. I've now created the admin badge by doing this, but I haven't done anything useful with it. And what I'm actually going to do is I need to give this back to my caller so that they will have the admin badge and they can do something useful with it. So I'm no longer just going to return a component. I'm now going to return a tuple, which has the component, and a bucket, which is going to contain my admin badge. Other thing I need to do here is I need to track just call it admin badge for simplicity, the resource definition of that admin badge, because when I set up my authorization, I need to know what resources are permitted. So now when I'm initializing, I need to also set admin badge to be admin badge.resource-def. Again, code completion normally works here. I'll try restarting my environment after this and see if that fixes it. And I need to return tuple with Gumball Machine and my admin badge. That will get my caller the same instantiation they got before, except for they also now get back, in addition to the component itself, they get back to place within their account the admin badge, which will control the thing. And now let's add authorization to this, which is done like so. There's this little macro for authorization. We do auth, and then we put in what is the resource definition or address of the thing that is going to permit that authentication. And now Radix Engine will, on your behalf, automatically make sure that nobody can call collect XRD unless they are presenting this admin badge that's defined here. So let's run this, and because I changed the contents of my struct, I now have to, I can no longer just publish to the same address as I was at before. I'm going to reset my ledger, and I'm going to publish to a new package address. And I will need a new account to run as. And now I'll be able to instantiate a new Gumball machine and actually try this out. So we'll do call function on my package. It's still a Gumball machine. And call new. Let's make our price 5 this time. We successfully, this time we created 2 resource definitions. The first one was gum. Second one was our admin badge. And then we have our component address. So at the moment, if I look at our component, you'll see that I have no collected XRD. Let's change that. Let's call our buy Gumball with some XRD. We'll oversupply the amount I need. And what have I made a mistake on? I'm uncertain component by Gumball, $100 XRD. Do I not have XRD exported? Ah, cleared my variable. That was my issue there. Okay. So now let's run that a few times. And if I look at my account, I have 5 Gumball Machine, or excuse me, 5 Gumballs. I've spent 25 XRD because the price is now 5, and I have my Gumball admin badge. If I look at the component itself, I have 25 XRD, which I'd now like to go collect. So first we'll try to collect it. Collect X on our component. We'll try calling it with no parameters, which as you see here is what you'd actually expect here. And when I do that, I'm going to get an error. I'm missing a bucket ref here. In this case, I'm missing my authorization, my admin badge. So I will remedy that by passing in one admin badge, which I now can't remember if I called it admin or admin badge. I think this is right. Yes, it was. And so now that worked successfully, and if I look at my component, I will see that all of that collected XRD is now removed. And if I look at my account, I'll see that I'm back up to 1,000,000 XRD. So I will stop there for this demo. We've been going on long enough on these basics. This example that I created here is available in the Gumball Machine example itself in our core part of the examples, or something very similar to what I've created here. And from here you have the basics down of how to create fungible resources, how to pass them around between components, and how to authorize at will if you want to have privileged methods. And we'll call it there for today. Thank you.